All right. Good afternoon, everyone. I'm Joe Tortorelli. I'm a DevOps Solutions Architect at CDI, and I'm here to talk to you today about infrastructure as code and Hashicorp's Terraform product. So a quick background on me. Currently, in my SA role, I support our sales and delivery teams on everything DevOps related from a pre-sales standpoint. But before I moved into my current role, I spent a number of years in our DevSecOps practice handling a number of different projects and a number of them in this Terraform infrastructure as code space specifically. So that's why I'm here today to talk to you a little bit about the topic. And with that said, let's get started with the agenda. So today we're going to be talking at a high level about infrastructure as code and HashiCorp's Terraform, right? So we're going to be taking a look at modern versus traditional infrastructure approaches. We're going to be taking a look at leveraging and the benefits of infrastructure as code. We're going to be taking a look at the same for Terraform, and then we're going to be taking a look at a demo of Terraform. So with that said, let's get started on taking a look at the traditional infrastructure approach. So in the past, infrastructure engineers would typically do a lot of pointing and clicking, a lot of manual process in web interfaces like vSphere, AWS, Azure, etc. So it's a very manual process, but the workloads at the time enabled us to manage them that way, right? So, and when I say workloads, it wasn't just the workloads, it was the infrastructures, right? So the infrastructures, like the VMs would oftentimes live for months to years, right? So it's much easier to manually manage something if you know it's going to stay there for quite a long time. And as a result of this, we'd often see or go onto customer sites and see developers hanging on to VMs often for dear life, right? Because they didn't know when the next one could be provisioned and configured. There was just so much red tape or process surrounding getting one, provision set up that there was no certainty around how or when they would be able to get the next VM to run their workloads. Aside from that, scale, right? So scale was certainly not, or the demand for these applications was certainly not as high in years past. It seems like demand is only growing. We're introducing more and more devices, mobile phones, hybrid applications, what have you, tablets. So as a result, these applications need to scale and be architected much differently to handle the scale. And lastly, this infrastructure was fixed, right? So kind of as we mentioned on one of the previous bullets, it's these infrastructures were spinning for a really long period of time, right? They were sitting in a data center, spinning 24/7, 365. And as a result of them being so fixed, the cost was fixed, right? So there was little that we could do to take advantage of cost savings or enable us to maybe turn the lights off every once in a while. But this is all obviously, being disrupted now. It's something that we've seen we need to change, and the disruption is here. So we can talk a little bit about now, the acceleration into this modern world, right? So now everything that we're seeing is certainly trending towards the API-driven model or the code model, right? So everything is now API-driven, where it's either code or a REST API endpoint. So that enables us to much more easily integrate our tools and systems, as well as bolt on or take off different pieces or components of these applications or systems. And to dive in a little bit more on these workloads, right? So now we're looking at highly elastic workloads where no longer are they living for months to years, but rather we're looking at stuff that's living for hours to days or sometimes less. So our infrastructure and our workloads are very highly elastic, right? We're seeing them at much greater scale now. So now I mentioned all the devices that we're seeing. These workloads are split up now into many different microservices in order to handle the scale. So no longer are we looking at a monolithic application or a simple 2 or 3 tier application. We're looking at widespread microservices that require a service mesh or something similar to configure and allow our microservices to communicate, so you can understand or appreciate the complexity of some of these workloads. And now our workloads are highly cyclic, right? So as I mentioned on the last slide with cost savings, now we're able to turn the lights off, right? So we're able to turn off certain components or areas of our workload if we're no longer needing the demand or there is no demand, but we're no longer needing the capacity, right? So we're able to spin up or spin down our workloads depending on a number of different criteria. The only issue, though, is a lot of this old process, are now looking like bottlenecks, right? So, you can imagine if we're trying to spin up and spin down 1,000 different workloads, no longer are we going to be able to fill out a manual ticket request or update 1,000 tickets. It's just no longer sustainable. So now we're seeing a number of tools trend in this direction, and infrastructure as code tools are certainly part of it. So let's talk a little bit about infrastructure as code, right? So what is it? So infrastructure as code produces a codified artifact, which what that means is no longer is the artifact just the completed virtual machine, right? No longer is it just the finished VM is the artifact. No, now it is a markup file, right? It's a file of code that we're able to take and pass to a infrastructure as code engine, have it apply it to our environment, and it will spin up exactly what we're looking for. So the artifact now is the code. And we'll talk a little bit more about some of the benefits that offers. So like I mentioned, this code now provisions and configures our infrastructure by passing it to these engines. This code is declarative by nature, right? So we're not programming or telling these tools exactly how to get to the state that we're looking for. We're just telling the tools exactly what we would like to see out of our environment, right? So these tools are declarative, right? The code is declarative. We're telling it what to do as opposed to imperative, where we would be telling it how to do it. The syntax for this code is human readable, meaning we're not looking at complex languages like Golang or C# or Python or what have you. We're looking at markup languages like HCL, JSON, YAML, etc. So it's much easier for non-software developers, non-software engineers, or someone without a software engineering background to get up and running with some of these tools. And a number of these tools, if not all of them, are open source and widely available to take advantage of, right? So you'll find online a number of different repositories on GitHub leveraging, Ansible playbooks or, Terraform TF files or anything of the sort. You'll often find a lot of these artifacts laying around in open source communities for the community to fork, consume, improve, and use in their own environments. So how does infrastructure as code help? So it sounds great, but how can we use it to help us in our business, right? So first, one of the issues that it addresses is documentation, right? So no longer is the complexity of our environment no longer is it a black box. No longer is it living in the heads of one or a couple of our engineers. Now it is explicit documentation, step by step, or in our case, it's the state. It's not necessarily the steps of how you get there, but it's the state of where you're going. We're looking at it in the code, right? So that's documentation, and it's an intrinsic benefit to adopting an infrastructure as code tool. And I mentioned we're going to talk a little bit more about what having a codified artifact affords us, right? So now engineers can collaborate, right? So now we can collaborate to incrementally improve the code and as a result improve our environment, which you could imagine was much more difficult leveraging the traditional approach because you can't have two people clicking on a mouse or you can't have two people tapping on a keyboard at once, touching the same web interface. You can imagine they would oftentimes be kind of stepping all over each other, but that's no longer the case with infrastructure as code tools and leveraging the capabilities of these infrastructure as code tools. Now we're able to, as I mentioned on the next point, work in version control systems. So we're looking at something like GitHub where we can commit and pull down and do diffs on our code and see exactly what's changed and how it's changed and collaborate as a team on our infrastructure. No longer is that segmented to just the application teams. Now we've brought that over through infrastructure as code to our infrastructure operations teams. And we're also able to leverage CI/CD pipelines, right? So we're able to take those codified artifacts and work them into our CI/CD pipelines in order to improve our process, in order to further our automation pipeline and our automation capabilities. So you can imagine if you have a CI/CD tool like something like Jenkins, you're able to take perhaps values from different systems or different areas or different computations and dynamically inject them into your Terraform code. So we're able to dynamically update and configure some of these tools and leverage some of the capabilities in CI/CD. And then obviously our infrastructure as code tools and what they provide us, it's easily repeatable, right? So you can imagine if we have a production environment that we know is in the correct state, and we want to replicate it, all you have to do is apply that particular infrastructure as code artifact to a different environment or whichever environment you'd like, maybe update a tag or two, and you're off and running. You now have the same replica of your production environment, and you can take away the concern for human error or potentially anything going wrong there. So great. All right. So now we talked about infrastructure as code. Let's talk about Terraform specifically. So CDI is quickly recognizing Terraform and HashiCorp specifically as a leader in this infrastructure provisioning space, right? So we're seeing a number of different customers that start adopting Terraform. We're seeing a number of different vendors adopt Terraform into their native into their systems. We're just seeing that adoption, and the writing is on the wall for everyone trending towards this direction. So how do we get started, or where can we get started? What packages are available? So Terraform offers an open source, a cloud, and enterprise offering of the product. Most often we see folks get started on the open source and quickly graduate to either the cloud or enterprise offering. Depends on a number of different criteria or what we see in that environment. But we see a range of these different offerings, in our customer systems or in our customer environments. Depending on whether it's development or production or what have you. So aside from that, we have an enormous already and growing community of developers and engineers, which makes getting started in operating Terraform much, much easier. And Terraform is written in HTML or JSON, right? So you don't have to, as I mentioned, know a complex programming language like something like Golang or C# or JavaScript. All of the languages that you would use to program Terraform are human readable markup languages that are easy for anyone of any background to pick up. So let's talk about Terraform's capabilities. So Terraform affords us the ability to provision and configure infrastructure just from code, right? So we're able to take as you see there on the right-hand side of the screen, we have an EKS resource that we specify in our Terraform code, and we're able to take that, apply it, and push it up to our environment, and now we'll have an EKS cluster in our Amazon environment. And there's a number of different ways to trigger it, right? So we could use the CLI, the API, the UI like we used to, or trigger it from version control systems. So we have a number of different ways how we can trigger or kick off our automation through Terraform. Terraform provides an infrastructure state file. So you have either a locally or remotely stored state file that you can leverage so you always have an inventory of the machines in your environment. No longer is that piece of the puzzle a black box either. We have an extensive inventory of providers, right? So you can imagine, with everyone seeing the adoption of Terraform, all these companies, software developers, and software products are building Terraform providers for their products so that people can leverage their product through Terraform. So you can imagine stuff like AWS, vSphere, Azure, GCP, all of them have a Terraform provider that you can use to provision infrastructure and configure infrastructure in their environment. And native integrations is a piece I wanted to touch on. So we're seeing a number of companies like Cisco or VMware. They're building these native integrations into their software products, right? So Cisco's Intersight service is natively integrated with Terraform Cloud for Business. We're looking at the same thing for VMware with their VRA product. You're able to natively build Terraform out of these products because, like I said, these vendors are seeing the adoption of Terraform and they'd like to leverage it in their software and systems. So very cool to see a lot of our partners, a lot of these vendors pick up Terraform and bake it in natively to their products. And we mentioned already, but the open source cloud and enterprise packages are the three packages available of Terraform, and we can dive in a little bit deeper on the next slide on that. So, like I said, we have the open source, the cloud, the enterprise packages of Terraform. We often see a lot of our customers start at the open source and quickly graduate to either the cloud or enterprise offering, depending on what fits their needs the best. You can kind of see by the diagram, the enterprise and the cloud paid feature sets afford you a number of capabilities specifically around the policy and governance, self-service, and, the support obviously comes along with it. So these things are all available, in the paid feature sets of Terraform, which is what we recommend for production environments for our customers, right? So we wouldn't recommend going the open source route where you don't have any of this security or hardening concerns addressed. And we're actually going to talk about that on the next slide as well. So Terraform policy and security, right? So obviously, if you have Terraform, you want to make sure it's secure and all of your necessary security concerns are addressed, right? So that's why we, like as I said, CDI recommends going the Terraform Cloud or Terraform Enterprise route for production workloads. So leveraging either Terraform On-Prem or Terraform Enterprise, where you can install and configure Terraform in your on-premise environment, or Terraform Cloud, where you're able to leverage the cloud capabilities of Terraform through their software as a service product. Enterprise is a paid feature set, and Cloud has a paid feature set as well. So with these tools, you get RBAC controls, you get Sentinel capabilities, so you're able to leverage the policy as code, which shares a lot of concepts with what we're looking at with infrastructure as code. You're able to leverage those same concepts and policy to really clean up and harden your environment. And as we mentioned, an extensive list of providers are available, and it's no different for the tools in the security space. So obviously Hashicorp's Vault, which is a sister product to Terraform, is one that's available and has a provider, but there's also many, many other security products that have a similar provider for Terraform. So let's take a quick look at the entire Hashicorp stack. See Terraform on the bottom. I mentioned Vault in the last slide. Console and Nomad are also two products. These aren't all of them that HashiCorp offers, but these are the main four. Terraform obviously integrates with all of them, and we're seeing a growing adoption for some of the other three, but certainly Terraform is the one gaining the most steam or has the most steam currently. But we're looking forward to provide our customer support in any of these other products as well. And so with all that said, let's hop into the demo. So let's get started on that. All right, guys, before we hop into some Terraform code, I did want to show everyone the list of providers available on the Terraform registry. So I know we were mentioning it in the slides, but there is a rather extensive list of providers that Terraform has available to it. So you'll see up here, we have some of the big cloud providers. We have Kubernetes, and we got a number of other tools that have providers that integrate with or that are available for Terraform. So just wanted to point this out, that whatever tool you may be working with, developing on, what have you, there should be a Terraform provider for that tool. In the event that there's not, you could always create your own provider, but very often, we'll see that the tool that we're looking to develop with or integrate with is often available here. So just wanted to point that out before we got into the Terraform stuff. But with that out of the way, let's take a look at our Terraform environment. So now we're over here in our Terraform environment. I'm taking a look at the Terraform configuration for a EKS cluster. So really what we have here is, to back up a step, is we have an AWS configuration or Terraform configuration. We have Azure AKS Terraform configuration. And then we have some automation scripts in a directory above that leverage that. So we're going to be taking a look at some of the automated stuff towards the end, and we'll see exactly how we're going to be provisioning and wrapping some automation around Terraform. But first, I just want to take a look at some of the code that we were sort of referencing in the slides. I mentioned how the code is often, it's human readable, meaning, and what I meant by that was that, anyone can really take a look at this and see kind of what it's doing, right? So, I mean, you see, we're referencing a AWS module here. We're obviously naming our Kubernetes cluster that's going to go into AWS. We're specifying the cluster version for Kubernetes 1.18. We're doing a few other things like naming or providing tags, providing more detail on our Kubernetes nodes, et cetera. So, and there's tons of documentation available online for this particular module, as well as many other modules. So if you ever need to refer to it, there's nothing against that. But just wanted to show you what we're going to be working with and sort of what that Terraform code looks like. And then once we apply that, I do have a state file, a sample state file here of what it may look like when you're poking around a state file. And this is what it would look like when we're after we applied the configuration that we were just looking at before. This is an example of kind of what we would expect, right? You see a number of your resources that Terraform applied. You have a ton of detail in here about it. But basically the point I just wanted to drive home was that Terraform does record state and have a record of your resources that you provision through it. And it's always available. In our case here, we're leveraging or using Terraform open source, so it's locally stored state. But in the event that you're using Terraform Cloud, you could be using remote state or something like that. So, but just wanted to point out exactly what that looks like and sort of what to expect. But with that out of the way, we can hop over to our automation file and start taking a peek at what that looks like. All right, so now we're over here in our automation file. Really what it is just a bash script that I'm wrapping Terraform in some other automated commands around. So, at the top you see, this is where we leverage Terraform. You see us calling Terraform CLI. Like I said, we're using Terraform open source. So we're just calling the CLI. We're providing the directory that we would be leveraging. And then we're just running the apply on it. So the apply command would actually take that Terraform configuration code and apply it to our environment. In this case, the endpoint would be AWS, and in this, it would be Azure, just based on the modules we specified. Sort of like we were looking in the code in the last example you saw was landing in that EKS module. So that'll make sure, and Terraform will make sure that it gets routed, or all your configuration gets routed to the right place. But that's what's happening there, and we're setting auto approve just so we don't have to deal with the prompts that will come up that make sure that we actually do want to change our environment. So with that out of the way, below that we have a number of other shell scripts. So these are just bash scripts that basically, we're updating our local Kubernetes configuration file, which really isn't too related to Terraform, but basically we're just taking details from that configuration, grabbing it, and we could potentially use it to, in this case, we could even, attach a dynamic name instead of this AWS attached cluster name. But that's basically the idea is we're going to be spinning up a Terraform Kubernetes cluster. So that's basically what's going to be happening here is we're going to be taking Terraform to spin up an AWS and Azure cluster, Kubernetes cluster. Then we're going to be taking that, and then we're going to be performing a number of different operations on it. Namely, we're going to be getting updating our Kubernetes configuration file. We're going to be setting our contacts, and then we're going to be actually integrating with Tanzu Mission Control and attaching those Kubernetes clusters that we just spun up to Tanzu Mission Control. And then we're going to be creating deployments and actually deploying an application on our Kubernetes cluster. So this is an example of how you could take Terraform and actually create infrastructure on the fly, and then do a number of automated tasks after you create that infrastructure on that infrastructure that you just created. So this kind of gives you an idea of what you could do with CLI, but just know that there's a number of other triggers that you can leverage, like the API, and I mentioned also version control system triggers as well. But this kind of gives you an idea of what, kind of what Terraform is capable of and how you could potentially leverage it. This is actually a relatively simple example, but let's hop in here. So I'm down here in a terminal or my Visual Studio built-in terminal, and I'm just going to run a bash automation.sh, and that is going to run this automation, and we can cut it and take a look at it in a few minutes when this is fully deployed. And before we cut away here, I will show our environment. So you see here's Tanzu Mission Control. We have nothing in here. We have our empty Azure, aside from just a few networking things in here that were related to something else. And then we have our AWS attached cluster, which is already spun up. You can see that EKS has already done that, but soon we'll have a status and have more details on it, and we will see everything will be automated in our environment. So we'll pick back up in a few minutes once this is all set. All right, guys, so we can see that our bash script completed here. We can see all of the configuration that we did, or all the bash shell scripting that we did. We see attached Tanzu Mission Control. We see all of our Terraform configuration running here. So we saw it for Azure below. We see it for AWS here. So let's take a look at our environments and see what we were able to build here. So if I pull over our AWS environment, so you'll see now we have a status in here for our AWS attached cluster. If we come in here, you'll notice that the configurations is the same as we specified in our Terraform configuration. So we have those 3 nodes, 2 small, 1 medium. We have our workloads in here. we'll see the Nginx one at the top there. And, our configuration, like I said, we have Kubernetes version 1.18, like we specified, so on and so forth. So EKS looks good. And if we pop over to Azure, Azure looks good as well. So we see a number of our Kubernetes components in Azure. We see our Azure attached cluster. So that all looks great. Looks like Terraform provisioned everything properly. And even if I pop over here, we have our AWS Elastic Load Balancer host name right there. And it takes us to our Nginx deployment. And then we have our Azure IP address here to our load balancer, and we see it takes us to our Nginx application. So the deployment of these Kubernetes clusters went through Terraform went well. So we see we're able to deploy Kubernetes clusters in 2 different public clouds, and then deploy applications on top of them all on the fly through one script. And even if we come over to, you see me looking at the Astra cluster here, we have everything in Tanzu Mission Control. So everything looks healthy. Our clusters are built by Terraform, ready to be managed by Tanzu Mission Control, and we have applications deployed on them. So we can hop back to the code over here. So basically, in summation, we were able to build out a simple Terraform example where we were building Kubernetes clusters, which is certainly not a hello world demo, but we were able to easily build out these clusters in 2 different public clouds. We were able to run some shell scripting or wrap some shell scripting around those clusters after they were built. And then from there, expose some applications on those clusters that were just built so that we can now use. And you saw those 2 Nginx applications on both clouds. So it appears that we're ready to go. So now we can pop back over to the slides real quick and just finish up on our last slide here, which is, the thank you to our sponsors for TechSummitIII. So thank you to our sponsors. And if anyone has any questions based on any of the demo or the slides or anything that you saw, please don't feel free to reach out to me. Let me know. Certainly, we'd be more than happy to talk about some of this stuff with you. Or potentially, if you'd like to see another demo, something more in depth, we'd be more than happy to set that up for you as well. So appreciate the time and looking forward to speaking with anyone, on anything Terraform or infrastructure as code. So thanks again, guys.